recording of so first type is row matrix. Okay, so row matrix is basically we have a simply arrangement along a row. So we can write, for example, like this is matrix A. So we have 1, 2, 3, 4. So this is a row matrix. Okay. So second type is basically column matrix. So what do you mean by a column matrix? If we arrange all element in a column, then simply a matrix is known as column matrix. So for example, A equal to 1, 3, like this. Okay. So if I would like to write down the order of a matrix for these two particular matrices, so what will be the order of these two matrices? How order is defined? So let us first discuss about order of a matrix. Let us suppose we have a matrix. So if I write A1, A2, A3, B1, B2, B3, C1, C2, C3, then I can say the order of the matrix will be, because we have 3 rows and 3 columns, so 3 cross 3. So this is basically the order. So we do not multiply, we write in the terms of number of rows into number of columns. This is equal to order of a matrix. So here we have 3 cross 3. We do not write 9 by multiplying this 3 cross 3. Why? Because we would like to represent rows and columns separately. So if I write a matrix B like 1, 2, 3, 4, 5, 6, 7, 8, then what will be the order of this matrix? So how many rows are there? We have 3 rows. How many columns? 4 columns. So we have order will be 3 cross 4 for this particular matrix. Okay. So now if we talk about order of these two matrices, first and second matrix. So if we talk about order of this matrix, so we have 1 row and 4 columns. So we can say 1 cross 4. So if a row matrix, then order will be always of the form 1 cross n, because m value will be n. Okay. So if we write down general order of a column matrix, so what will be the general? So here row will be 3, column will be always 1. So general order will be basically m cross 1. Okay. This is clear to you? So next is square matrix. If m is equal to n, that means number of rows equal to number of columns. Then we can say the matrix is a square matrix. So for example, I can write down 1, 2, 3, X, Y, Z, A, B, C. This is basically 3 cross 3. So we have 3 row and 3 column. This is the example of square matrix. Okay. Next is a diagonal matrix. Diagonal matrix is basically a matrix in which all elements except diagonal are 0. So diagonal matrix is basically a type of square matrix first. In which all elements except diagonal element are 0. Okay. So for example of diagonal matrix will be A, B, C, 0, 0, 0, 0, 0. Okay. So we have this as a diagonal, leading diagonal. All other element other than leading diagonal will be 0. So we can say I11, or we can write down in general notation I is equal to 0 if I is not equal to 0, not equal to 0 if, or maybe not all equal to 0. So let us erase this. So next type of matrix will be unit matrix or identity matrix. Identity matrix is basically another type of square matrix in which all diagonal elements are 1, 1 and other elements are 0. So diagonal elements are are 0. So we can say identity matrix we denote by capital I. So if you would like to write 2 cross 2, this is basically also a type of square matrix. Oh, sorry, 1, 0, 1. This is 2 cross 2 identity matrix. If you would like to write 3 cross 3, 1, 0, 0, 1, 0, 0. This is 3 cross 3 identity matrix. Next is scalar matrix. This is also a type of this is also a type of square matrix. Okay. In which all diagonals are equal. but and all other elements are G. Okay. So for example, if I write a matrix A, so we have, let's suppose K00, K00, K, where K is not equal to 0. Okay. So this is a scalar matrix. I think this is clear to you, the basic types of matrices. Okay. So we can all write down like 500, 005, 005. So this is also a scalar matrix. Okay. Now we talk about null matrix. So what do you mean by null matrix? Basically all elements are 0. So let us, if I write 0, 0, 0, 0, this is also null matrix. So if I write, for example, 0, 0, 0, 0, 0, 0, 0, 0, this is also, so this is 2 cross 2. And here we have 2 cross 4 null matrix. Okay. So now let us talk about singular and non-singular matrix. So what do you mean by singular and non-singular matrix? Singular matrix is the matrix where determinant value of that particular matrix is 0. And non-singular is when determinant value of that particular matrix is not equal to 0. So this is a singular matrix. And this is non-singular matrix. Okay. Now let us talk about algebra of matrix. Okay. So first thing is addition of two matrices. So can you tell me addition of two matrices is possible or not? If possible, when? What is the condition? Let us suppose we have two matrices A and matrix B. If order of both matrices are same, this is also M cross N and this is also M cross N, then we can define then A plus B is defined. Okay, so for addition, order must be same. So what is the condition? Order should be same. Okay, so for example, let us suppose I have a matrix A, X, Y, Z, A, B, and a matrix B, 1, 2, 3, 4. So if I would like to write A plus B, then what will be the sum of these two matrices? So first check for the order. So order of matrix A is 2 cross 2. Here order is also 2 cross 2. Okay. So we can say then A plus B is defined as sum of their respective element. First element is added to first element, so we can say X plus 1, Y plus 2, A plus 3, B plus 4. So we can generalize this term for addition and subtraction too. So let us suppose we have a matrix Aij and B matrix Bij. If order of A is equal to order of B, then addition and subtraction both are defined. And subtraction both are defined. Okay. So A plus B is defined as sum of Aij plus Bij, respective element. Okay. And A minus B is defined as Aij minus Bij. Okay. So let us suppose we have two matrices. So let us try to solve one question based on this particular question. So my question is that if I have a matrix A as 2 minus 1, 3, 1, and B as 1, 4, 7, 2, then find A plus B and 3A minus 2B. So first thing, simply we have to add these two matrices. So for addition, first we need to check out the order of these two matrices. So we have matrix A. So we can say order is, that is 2 cross 2. And order of B is also 2 cross 2, isn't it? So order of both the matrices are same, so we can define A plus B. So here we have 2 plus 1, that is 3. Minus 1 plus 4, that is also 3. So here I have 3 plus 7, that is 10. 1 plus 2, that is 3. Now we need to find this matrix. So how do we find out 3A? 3A is simply to find out 3A minus 2B. First, we need to find out 3a value. 3a value is basically scalar multiplication of a matrix by a factor of 3. So this is defined as 3 into matrix A. So 2 minus 1, 3, 1. So if I multiply with this scalar number, this is known as scalar multiplication. So I have 6 minus 3, 9 and 3. Yeah. So respectively, I have 2b value. So that is 2 scalar multiplication with matrix B. 1, 4, 7, 2. So can you tell me what is the value of this 2b matrix? So this will be equal to 2, 8, 14 and 4. So now I need to find out 3a minus 2b. Okay, so what is the value of 3a? This is the value of 3a. So 6 minus 3, 9, 3 minus, what is the value of 2b? 2, 8, 14 and 4. So if we subtract these two matrices, so finally I have, that is 4 minus 11, I have minus 5, minus 1. This is the final answer of this particular question. Okay. So this is clear to you. Addition, subtraction, basic operation. Alright. So next thing in algebra is multiplication of two matrices. So this is very important. So let us suppose I have a matrix A. This is matrix A, whose order is, let's suppose, m cross n. And I have a matrix B. Okay, so let us suppose its order is P cross Q. Okay, so to define multiplication of two matrices, first we need to check they are comfortable for multiplication or not. So if the condition is that if number of A is equal to number of rows in matrix B. Okay, so we can say here n should be equal to P. Okay, so if number of columns of A is equal to number of rows in B, then we say A cross B is defined. Okay. A cross B is defined. So now come to how we define A cross B. Okay. So let us suppose I have a matrix A. Let's suppose this is 2 cross 2. So I have A1, A1, 2, A21, A22. Basically, we write in this manner to represent specifically the particular elements. These are the elements. So we have B matrix. So this is 2 cross 2. So I should write, let us suppose 2 cross 3. So I have V11, V12. So I have V21, 22. Okay. So now if I would like to define A cross. So let us check for number of rows. Number of rows, number of columns. A should be equal to number of rows in B. So let us check for that. That 2 is equal to. This is correct, isn't it? So if I would like to write A cross B. So we have the final order of A cross B is basically this 2 get cancelled. So order of this will be 2 cross 3. Okay. So this will be 2 cross 3. So here I have first element R1 from this. Let's suppose this is R. This is R2. And here I have C1, C2, and C2. So R1, C1, R1, C2, R2, C1, C2, R2. These are the element of A cross B. So now we need to find A cross. So to find out R1, C1, R1, C1 means this row is multiplied to common. So we will write A11, B1 plus. Okay. So I have A21, B21. Okay. If I would like the second element, so here I have R1, C2. So R1 is A11 and that is B12 plus A12 B22. Now A11 B13 A11 B13. Now we have A12 B2. So these are the elements of first. Now if I would like to write this, then R2 C1. So I have A21 B11, then A22 B2. Here I have, for this place, I have A21 B12. Okay, so here I have A22 B2. Here I have A21 B13. I have A22. Okay. So this is A cross B. Okay. So this is how we define the product, and we can say A cross B is not equal to B cross in general. Okay. Okay, let us try with some example. So I have a matrix A in which elements are 2, 1, 3, 3 minus 2, 1 minus 1 0 1, and matrix B, that is 1 minus 2 2 1. Okay, so if I write, so I have 3 cross 3, and order of this matrix will be 3 cross. So now let us check for they are comfortable for matrix. So okay, so we need to find out A cross B and B cross. Okay. So let us check for whether A cross B is defined or not. So A cross B. So if we check number of rows, in A is equal to number of 3 is equal to 3. Isn't it? Okay. So this is defined. So we are going to write A cross. So first try to find out what is the order of A cross B. So simply write down order of A, that is 3 cross 3, and order of B, that is 3 cross 2. So cancel these equal. Then so finally we have 3 cross 2. So that means 3 row and 2 column. Okay. So if I write first element, so how do we gonna write first element here? So that is R1 C1. So this is R1. And this is R2. And this is R3. So here I have this is C1 value and this is C2 value. Okay. So R1 C1. So we have 2 into 1. 2 into 1 2 plus 1 into 2. This is also 2. And 3 into 4, that is 12. Now I have second element, that is R1 C2. So that 2 into 2 minus 4. Okay. So then I have 1 into 1 plus 1. 3 into minus 3, that is minus 9. Now I have to write down this element. What is the value of this element? So if I write, that is R2C1. So 3 into 1, that is 3, plus 2 into 2 minus 4. And 1 into 4 plus 4. And this element, this is R2C2. So we have 3 into 2 minus 6. 2 into 1 minus 2. 1 into 3 minus 3. Okay. So now this element, so this is R3 and C1 product. So that is 1 into 1 minus 1. 0 into 2 finally 0. And here I have 1 into 4 plus 4. Okay. So what is the value of this element? This is R3 and C2. So we have minus 1 and minus 2, that is plus 2. 1 into 0, 0. Minus 3. So now after simplifying this, we have A cross B value as 4, that is 16, that is 13, so minus 12. Here this 4 get cancelled, so this is 3. So here I have, this is 5 and 6 minus 11 plus 3 and minus 1. This is the value of A cross B, and order is 3 cross 2. So this is the answer for A cross B. Now let us check whether B cross A is defined or not. So how do we check whether B cross A is defined or not? Okay, to define B cross A, number of columns in B Okay, so what are the number of columns in matrix B? So let us check. B have 2 columns. Okay, and number of rows in A is 3. So this is not equal. So we can say this implies B cross A is not defined here. Okay, so this is possible when A cross B is defined, B cross A is not defined. So we can also conclude from this particular part. So A cross B is not equal to B cross A. Okay. So this is clear to you about matrix multiplication. Okay, so now we have some properties like A to the power 2, that is equal to A cross A. If I have A to the power n, that is simply equal to A into A into A n times. Okay. If I have like A plus B whole square, then how I'm going to write? This is equal to basically A plus B into A plus B. So if I multiply these two matrices, here I have A square, A into B, BA plus B square. This is the product. Okay? Whole square of A plus B. And one more that is important property. If I have determinant value of K into A, this is the determinant. So this is equal to K to the power n into determinant value. I have this matrix. Okay. So here matrix is multiplied by K sum. So scalar multiplication of the matrix. So now let us talk about trace of a matrix. So what do you mean by trace of a matrix? Trace is basically defined as sum of diagonal element of the matrix. Diagonal means leading line. So we can define trace of matrix A is sum of the diagonal elements of a square matrix. For example, let us suppose I have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I can say this is matrix A. So trace of matrix A is equal to sum of leading diagonals. So leading diagonal will be this diagonal. Okay, so that is equal to 1 plus 5 plus 9. So this is 15. This is defined as the trace of matrix A. Okay. So next thing is transpose of a matrix. So how do we define transpose of a matrix? If we convert rows into columns, okay. So let us suppose if I have a matrix A whose elements are AIC, then A transpose. This is the notation to write down transpose. That is equal to B, yeah, or I can say AGI. Okay. So for example, how do we write transpose? Basically, let us suppose I have matrix A11, A12, A13. Okay. So B11, B21, A21, A22, A23. So now if I would like to write A transpose, then row is converted into column. So this is row 1 and this is row 2. So this row 1 and row 2 is converted into column 1 and column 2. So if I convert this into a column, okay, so I have to write down A11, A12, A1, and corresponding to this row, if I convert this row into a column, then I have to write down A21, A22, A22. So this matrix is known as A transpose. So now I think this is clear to you. How do we find out transpose? So let us discuss with some examples. So I have a matrix like 1, I have 3, 4, 5, 7, 8, 10. This is the matrix. Find B transpose. Sometimes this is written like this, or this is also written like this. Okay, these are same notation for transpose. Okay, so if I write down B transpose here, so I have 0, 1, 2, then I have 3, 4, 5, I have 7, 8, 10. This is the B transpose. Okay, so we have some important properties regarding transpose. First property is transpose of a transpose that is equal to A. Okay, so we can prove this with the help of this. Okay, so if we again take transpose of B, so we will get this matrix. Is it? Second property is if I have A plus B transpose, so that is equal to A transpose plus B transpose. Okay. Now if I have A transpose, okay, so hold this. First scalar multiplication with A, then taking the transpose. So this is equal to A into transpose. Okay, so here A is some scalar. Here A is some scalar number. So if I have A into B transpose, if we take product transpose, then this is equal to B transpose into A transpose. This is in reverse pattern. Okay. So these are few basic properties of transpose. These are the properties of transpose of a matrix. Okay. So up to this, you have any doubt? If you have any doubt, let me know in comment section first. Okay, fine. So I think up to this, you have basic idea about all those things we have discussed till now. All right. So now let us talk about conjugate of a matrix. So my question is that how do you define conjugate of a matrix? So conjugate basically, if you remember, we use this term in complex number, isn't it? We use this particular term in complex number. Okay. So if we have a matrix with complex number, then we can define conjugate of a matrix. Okay. So let us suppose I have a matrix A. That is 1 plus 2i, 2 minus 3i, iota basically. 3 plus 4 iota. I have 4 minus 5 iota. 5 plus 6 iota. And I have 6 minus 7 iota. Okay. And I have 8, 7 plus 8 iota. And 7. If I would like to write conjugate, that means conjugate is basically written with the symbol of like this, A conjugate. Okay. So if I write conjugate, so basically we are going to take conjugate of each element. So then this will be turned into A minus 2 iota, 2 plus 3 iota, 4 iota. Isn't it? Here I have 4 plus 5 iota. 5 minus 6 iota, 3 minus basically 6 plus 7 iota. Okay, so here this is remains same 8 iota. So this is 7, isn't it? So this is the conjugate listing. Okay. So now we define a next matrix with the help of this conjugate. So that is transpose of a conjugate matrix. Okay. So if I take transpose of a conjugate matrix, then I have 1 minus 2 iota, 2 plus 3 iota, 4 iota, 4 plus 5 iota, 5 minus 6 iota, 6 plus 7 iota, 8, 8 iota, 7. This is the transpose of conjugate matrix. So if I write down, okay, so let us try to solve one question. So I have a question, find the value of Z if the matrix A equal to satisfy the equation A transpose into A equal to I. Okay, this is the question. So try to solve this, take your time and answer. So what is the answer of this? So first I find out A transpose. So what will be the value of A transpose? This is 0 and this is equal to 2y and this is equal to z because rows are converted into columns. So here I have x, y minus z, x minus y, z. Okay, so now if I multiply, try to find out this product, so I can write down A transpose into. Okay, so what is the value of A transpose? So here I have 0x x 2y y minus y z minus z plus z. This is the value of A transpose. And what is the value of A? So A matrix is 0, twice of y, z, and I have x, y minus z. x minus y z. Okay, so here I have matrix 3 cross 3 and this is also 3 cross 3. So this is defined. There is no problem in the multiplication of A transpose into A. So we can say this is defined because so order will be here 3 cross 3, here we have 3 cross 3. So this get cancelled. So finally, so order is 3 cross 3 and defined. Alright. So now if we multiply these two matrix, so how we are going to multiply row into column. So here I have A transpose into A. Okay, so row into column, 0 into 0, x square into x square. So we have this element as 2x square, isn't it? So row into column. So I have 0 into this, x plus y, x minus y. So this is 0. This into this. So we have 2zy minus zy minus z. Okay. So now if I write down value of this element, so this is row 2 column 1, 0 xy minus xy. So I have 0 plus xy minus xy. Okay. So row into C2, I have 4y square plus y square and this is plus y square. Okay. Now 2 here I made mistake. This is basically this element is 0 and these two elements will be, because we are multiplying row into column 1, so this will be 0 minus zx plus zx. So what will be the value of this element? So this element will be 2i/z minus yz yz. Okay. So what is the value of this element? So this element will be 0 minus xz plus zx. And this element here, so if I multiply R3 into C2, so I have 2yz minus yz. Okay. And then I have again y minus yz. And third element will be z square plus z square plus z. So finally I have value of, after simplifying this, so can you tell me after simplifying what is the value? So this is equal to twice of x square. This is 0. This is 0, 6y square, 0, and this is also 0, and this value is also 0, and this is 3z square. And this is equal to I. Okay. So we have one zero zero. Okay, this is 3 cross 3. Same order. So if I equate these two matrices, so this implies 2x square equal to 1, 6y square equal to 1, 3z square is equal to 1. Now find out the value of x, that will be plus minus 1 by root 2. Y value will be plus minus 1 by root 3.
but I'm focusing on IIT-JEE pattern.
This is the answer for XYZ. So I think this is clear to you. Okay, so if someone asks how many matrices are possible, so if I change this question, so second question related to this, how many matrices are possible? Little bit use PNC, permutation and combination. So basically we have three unknown x, y, z, or we have two possible values for each. So we can say 2 cross 2 cross 2. So basically 8 different matrices are possible.
And इसलिए मैं कह रही थी कि फर्स्ट सेक्टर से पहले ही आप रजिस्ट्रेशन करवा लो, सीट रिजर्व कर दीजिए आप, ठीक है, क्योंकि इससे क्या होगा मैंने आपको टाइम
Okay, fine. Okay, so I think till now you don't have any problem. All right. So let us try to solve some more problem. So next question. So I have a matrix 80. This value is given to us, that is cos theta sin theta minus sin theta. Oh, let us write this is theta and cos theta. This is the value of A theta matrix. Theta is, then prove that RS into, we can say R theta into RT is equal to R S plus T. Okay. So try to solve this particular question. Okay, so first we need to find out this product. So we have R. This is basically so A theta value is this is cos theta sin theta. Okay. Now if I write 80, so 80 value will be cos t sin t minus sin t cos t, isn't it? So if I write down this, then I have value as cos theta sin theta minus sin theta Okay, so if I define product, so we have row into column, so cos t, theta cos t, sin theta, sin t. This we have cos theta, sin t, minus cos theta, sin t, isn't it? So if I write this fourth element, so I have sin theta, sin t, cos theta, cos t. So if I solve this particular, so value of a theta and at will be, okay, what is the value of this? So this is basically cos theta plus t, cos a plus b formula. And what is the value of this? This is sin a plus t. So we can write theta plus t. What is the value of this element? So this is basically, if I take minus sign as a common, so this is again sin a plus b formula. So sin theta plus t. And what is the value of this element? So this element will be basically cos theta plus t. Okay. So now let us try to find. Okay. So we have this cos theta plus t, sin theta plus t, and minus sin theta plus t, and cos theta plus t. Okay. So we can say a theta into at, that is equal to a this. Okay. Is there any problem till now? Okay, fine. So let us try to solve few more problems. Okay. So let us define two more things. Second thing is symmetric and skew symmetric matrix. Symmetric and skew symmetric matrix. So what do you mean by symmetric and skew symmetric matrix? First, if A transpose is equal to A, then A is symmetric matrix. And second thing, if A transpose value is equal to negative of A, then we can say A is skew symmetric matrix. Okay, so this is clear to you. Okay, so if I write down some example for this, so okay, this matrix. So now if I try to find out A transpose, so what is the value of A transpose? So I have 3 minus 1 plus 1, then I have minus 1, 2 into 5, I have 1. So now if I check, this is 3 minus 1 plus 1 minus, so all elements are equal. So we can say A transpose is equal to A. So here this is the example of symmetric matrix. Okay. So if I take example of skew symmetric matrix, then A transpose equal to negative of A. So for example, I have, let us suppose A, B, C. Okay. So I can write down this diagonal elements will be 0. 0, 0, 0. And then this is basically minus 3, 5, 3, 2. And this is minus 3. So this is A. So if I take transpose of this matrix, so I have 0, minus 3, 5, 3, 0, 2. So if I take minus sign common, then I have 0, minus 3 plus 5, 3, 0, 2. 0. So this is equal to A again. So we can say this is the example of skew symmetric matrix, isn't it? This is clear to you? Alright. We can express a matrix using in the sum of symmetric and skew symmetric matrix. Okay. So if I have a matrix A, so I can express this as half of A plus A transpose plus half of A minus A transpose. So this particular part is known as symmetric matrix. And this is known as skew symmetric matrix. Okay. Okay, let us try to solve one example based on this. So let us suppose I have a matrix A as six minus plus 6. then express the matrix A as sum of a symmetric and okay. So I have this matrix as A. So if I express A as a sum of symmetric and skew symmetric parts, so I would have to write A plus A transpose and half of A minus A transpose, isn't it? Alright. So now if I value of A is basically 6 minus 2, 2 minus 2, 3 minus 1. Okay. So if I take A transpose, then what will be the value of A transpose? So what will be the value of A transpose? A transpose will be 6. Okay. So if I take transpose of third row, then I have 2 minus 1, 3. Okay. So this is the value of A transpose. So if I find out symmetric matrix, so this part is symmetric matrix part, and this part is okay. So if I take sum of these two matrices and then take half, so 1 by 2 of so 6 plus 6, 12 minus 4, then I have plus 4 minus 4, 6 minus 2. Here I have 4 minus 2 and 6. Okay. So if I take half of this matrix, then what will be the value of A plus A transpose half? So if I take half of all these elements, because this is scalar multiplication here, so this is equal to 6 minus 2 plus 2, isn't it? We are just taking half of this matrix, so just scalar multiplication by a factor of 1 by 2. Minus 2, 3, minus 1. So this is the symmetric part. Okay. So if I would like to check for skew symmetric part, then I have to find out A minus A transpose. So first we need to take difference of these two matrices. So What is the difference of these two matrices? So if I take 6 minus 6, this is 0. This is also 0. This is also 0. Okay. So this is 0 again. So here I have 0. This is 0. This is minus 2. So I think we have made some calculation mistake. Let us check again in this particular matrix. Okay. So if I check transpose of this matrix, so this is I have 6 minus 2, 2. So if I take transpose of this particular row, so I have 6 minus 2 and plus 2 here. So what will be the transpose of it? So there is no negative sign here. Okay. So this will be minus 2, 3, minus 1. Okay. So minus 2, minus 1, 3. This is equal. So if I take sum of these two matrices, so sum of these two matrices, 6 plus 6, 12, minus 4, 0. Sum of these two are given. Minus 2, minus 2, minus 4. 3, 3, 6. Minus 2. This is 0. Minus 2, 6. So if I take half, because there is a factor of 1 by 2. So then I have 1 by 2. This is finally 6 minus 2, 0. Minus 2, 3, minus 1. 0, minus 1, 3. This is symmetric part. Okay, if I check whether this is symmetric or not, so let us take transpose of this. So if I take transpose of this, so what will be the transpose value? 6 minus 2, 0. Minus 2, 3, minus 1. 0, minus 1, 3. So this is equal to, so we can say these are equal. So this is a symmetric matrix. This is symmetric part of matrix. So now we need to find out skew symmetric part. So that is equal to half of A minus A transpose, isn't it? This is the skew symmetric part. Okay, so if I take difference of these two matrices, so we have so 6 minus 6, 0. Minus 2, minus 2. So this will be finally 0. So this will be plus 4. Okay. So minus 2, minus 2. This is 0. And this is 0 and 0. This is minus 4. 0, 0. So if I multiply with half, so finally I have This is 0, 0, 2, 0, 0, 0, minus 2, 0, 0. This is skew symmetric part. Okay. So if I would like to check, so I have to take again transpose. So this is equal to 0, 0, 2, 0, 0, 0, minus 2, 0, 0. If I take minus sign common, so then this is 0, 0, 2, 0, 0, 0, minus 2, 0, 0. So this is true. Okay. So I think up to this is clear to you. Okay, so let us try to solve few problems of JEE Mains 2019 and 20 asked in NDA examination. Try to solve this question. These are basically JEE Mains previous year questions. We have given a matrix that is cos theta minus sin theta, cos theta, then matrix A inverse minus 50, that is, then find the value. So we have a matrix A that is cos theta minus sin theta, cos theta. So we need to find A inverse. So what is the inverse of this matrix? So how do you define inverse of 2 cross 2 matrix? So A inverse is basically adjoint of A divided by determinant of A. And what is the adjoint of A? Transpose of cofactor matrix of A. Okay. So if I find out A inverse value of 2 cross 2 directly, so let us try to find out first what is the determinant value of A. So this will be equal to cos square theta minus of minus. So this is equal to cos square theta plus sin square theta. So this value is equal to 1, isn't it? So if I write down direct inverse, then we have to change the. So can anyone tell me what is the value of A inverse directly? Okay. So let us try to find out systematically. Then we make a direct formula. Okay. So first we need to find out adjoint of A. So for adjoint of A, we need to find out cofactor matrix. of A. So this will be for this element. So I have cos theta. For this element, I have sin theta. For this element, I have minus sin theta. And for this element, I have cos theta. So if I take transpose of this, anyone can tell me? First, okay. So then I have A inverse value. So what will be the A inverse value for this? So this is equal to So if I solve this, so I have I can write it down A transpose B transpose A. So this is basically A square into B, that is it. So if I solve this, so here I have A, so I can write down A upon B, that is 8. So if I substitute value of B here, so value of B is A by 8. So finally I have A cube by 8 is equal to 8. So I have A cube determinant equal to 64. So this implies determinant value of A is equal to 4, isn't it? So if I substitute again here, so find out the value of B. So this is equal to 4 divided by 8, that is 1 by 2. So this is the value of B determinant. Now we need to calculate this. So determinant value of B A inverse B transpose. So here we can write down B, that is 1 by A, and that is B transpose. So these two are equal, so we can say that this is equal to B square into 1 by 8. So if I solve this, so this is 1 by 4, and value of A is 4, so this is equal to 1 by 16 as correct answer, isn't it? So is there any doubt till now? Okay, so note down few program you have to solve at home. So this is system of equation. So you can solve this program at home. Okay. You have given a P matrix 3 cross 3 and this equation. This is Q minus P power 5. So you need to calculate P power 5. Okay. So basically there will be a pattern here because whenever we have some higher power, so to calculate that higher power, we always have some pattern. So if we do not have any pattern, you need to calculate it manually. Sometimes the question arises to make them calculated. Okay. So then you need to calculate all these elements and this ratio. Okay. Okay, note down this question 2. So this is a matrix. You need to find out determinant of this matrix. Then you have to tell for theta belongs to this particular interval 3 pi by 4 to 5 pi by 4. The determinant value of A lies in which interval? You have to identify interval here. So note down this question 2 for homework. Alright. So I think we have discussed this is basic thing about matrices. So we will discuss about the solution of equations and determinant in next lecture. So till then you practice all this program, and if you have any doubt let me know. No doubt. Okay, fine. So we are going to end this session. So in next lecture, we are going to discuss system of linear equation, homogeneous or non-homogeneous part, okay, and then how to find out solution, trivial solution, and all those things, okay, and basic properties of determinant. This we are going to discuss in next lecture. So I think up to this is clear to you. Okay, fine. So let us end this session here. So we will meet in next session. Till then, goodbye. Okay, take care.